Welcome to the ReThink Food Challenge by Wageningen University and Research. A groundbreaking competition designed to redefine the boundaries of food production through the lens of space farming. This is your call to action. As we face limited resources, a growing population and the challenges of climate change, your innovative ideas are needed more than ever. Join us in a quest to develop sustainable, circular solutions for food cultivation on Earth, Mars, and Moon. Work in interdisciplinary teams, identify real-world problems, and design viable innovations that bridge gaps in our current food systems. Get coached by experts, network with industry leaders, and gain exposure for your ideas. This is your chance to grow, to make a difference, and possibly to jumpstart your career in a direction you've always dreamed of. Join us in this transformative challenge and help forge a sustainable future for our planet.
Welcome everyone to the ReThink Food Challenge. Hi, my name is Natalie. I will be your host today. And I have to tell you, this morning I was getting some physiotherapy for my shoulder. So I was there laying on the bed, and the physiotherapist, he said, "Okay, so what will you be doing today?" And I said, "Yes, I will host an event." He said, "Oh, whoa, really cool. What is it about?" I said, "It's about space farming." He said, "Excuse me, sorry, what?" I said, "Space farming." And he started like getting these knots out of my muscles. And he said, "What is that?" I said, "Well, what a lot of people don't know is that there are so many innovations for space, but that we use here on Earth. And then there are these students of Wageningen University that come together with partners, with other researchers that actually create even more innovations for our daily life." He said, "Whoa, that's really cool." So I think it's really cool that you are all here that you signed up to create even more innovations. Because worldwide, 360 students signed up, and they formed over 44 teams. And today is the kickoff of this challenge. Are you ready? Yes, okay. Just to see who's in the audience here, if I call out your group or your name, please say yay! Okay. So if you work for Wageningen University, you can say yay! 1, 2, 3. Hey, okay. If you are a student, say yay! Cool. If you are one of the partner organizations that's working with the challenge, please say yay! Oh, cool. Anyone that I've forgotten, say yay! Okay. Well, thank you so much. Thank you all for being here. And I will open this challenge not just by myself, but I have a very special guest here on stage. She is the Rector Magnificus of the Wageningen University. So she's like the big boss here. Can I get a big round of applause for Caroline Kruse? Hi Caroline, welcome.
Thank you.
What did you bring with you?
I have something very special here.
Okay.
This is a time capsule.
Okay, a time capsule, yes.
And in this time capsule, I think we want to collect stories about what the ideal future will look like. Future of Earth, but perhaps also future of planets, Moon, Mars,
All right, and why is that so important?
I think it's important because what we want is that everybody has a say in the future and that we would like to challenge people to think about the ideal future.
And just to get an idea of what the future will look
Exactly.
like. All right. Well, then, of course, that makes me wonder, what do you think that future will look like?
Actually, my little story is already in the capsule.
Sorry, what did you say?
I said my little story about the ideal future is already in the time capsule.
Okay.
Where we also will collect that of others.
Okay, so we will collect also the stories from the audience later on.
That is the idea.
Okay, that's the idea. But first, let's hear your story.
Shall I take it out?
Yeah, shall I hold it for you?
Yes, please, because it's a little bit slippery. Yeah. So my story is here.
Okay. Wow, let's hear it.
Would you like me to share?
Would you like her to share? Yes.
So it will be short. So in my ideal future, there is a harmony between nature and humans. First of all, on Earth. And I think on Earth, what we would like to achieve in the future is that everybody will have met the Sustainable Development Goals of the United Nations. I don't know if you're familiar with them, but that would mean that we have an Earth with no hunger. We can live with climate change. We mitigate it or adapt it to it. There's clean water for all. There's biodiversity enough, etc., etc., etc. So that's on Earth.
Yes.
But I think in my ideal future there would be more. If we look at the moon or Mars, in fact what we would like is the same type of goals also there. So that we would have self-sustainable things over there, self-sustainability. Everything what we would be doing there would be circular, no waste, the waste would be a resource, and that there is planetary protection. So in fact, people planet profit, something that we want to have on Earth, we could also extend to Mars and Moon.
But you actually see us there, living there.
I don't know, but I think that is a challenge, huh?
Yeah,
that we are asking here.
That's the challenge.
But if we would do it,
yes.
I have no idea. But if we would, keep the people, planet, profit in mind and the sustainable goals that we want to achieve.
If we go only...
I think so. I think that would be my ideal future.
Perfect.
So that's why I wrote this down and put it in the time capsule.
We'll put yours in.
Can be back in here.
Cool. So yours is already in.
Mine is in.
But now it's time to collect the stories of others.
I think that's what you want, huh?
Yes. Can I first get a big round of applause for Caroline Kroeze? Okay. So this challenge is not just about working on these innovations, but it's also about networking, getting to know new people, and let's just start doing that right away. Now, what I would like you to do is meet up with one person you don't know yet and share. First, of course, you can introduce yourself. Hi, I'm Natalie. Hi, I'm Caroline, for example. And then share your vision for the future with him or her. So you can discuss with the two of us, what does your ideal future for Earth, Moon, and Mars look like? What does your ideal future for Earth, Moon, and Mars look like? You will first discuss that amongst each other, and then we will have a way to collect all of these stories from the audience at home. Of course, you can also share it in the chat and put that in a time capsule. So, meet up with one person you do not know yet. Introduce yourselves and share what does your ideal future for Earth, Moon, and Mars look like. You can stand up and mingle. 1, 2, 3, go! Okay. Okay, so I hope you had a lovely time discussing this and meeting with someone you do not know yet. Cool. If you can hear me, clap your hands twice. If you can hear me, clap your hands twice. Yes, everyone can take a seat. All right. So I told you we are going to gather all of your stories and put them in this time capsule. How will we actually do that? We will ask you in a minute to get your phone out and then scan this Mentimeter QR code. That's here. You can do that now. Then you can type a short version of your story in the Mentimeter. We will gather all of the stories, print them, put them maybe on a USB stick, I don't know, but we will put them in to make sure that they will be preserved for the future. So that 50 years from now, we can actually see, all right, what did the people back then want for our future? And have we actually succeeded in achieving this future? So you have some time for the Mentimeter to type in what you think the ideal future will look like. Yes. Somebody has to push a button because they are not getting through. That's what I heard back from the audience. No one's getting in. Oh no, yes. They pushed the button and now you are all in. So type in, what does your ideal future for Earth, Moon, and Mars look like? So the first one is coming in. Good job. I see other people still typing. Oh, there are a lot of things already on the board. So if you don't have inspiration, you can take a sneak peek of what others have already filled out. So I see a lot of things that were also mentioned before by Caroline. Also livable and circular. You want lower technical bottlenecks for a circular economy, so less difficulty. And a green and equal future is also important. So I see a lot of circular, green and equal. Has to be a balance. So you have 1.5 minutes left to fill it out. If you have already filled it out, and you think, I want to get to know another person. Just chat with a neighbor or someone you don't know yet. Network. Share your happy thoughts. If you are still typing, you still have time, don't worry.
Se lo confíen sin timidez. Curiosas las verdades que aparecen, buenas o malas, no las comprende. Intenta con amor mecer.
This is a song by Paula Sofia that you hear. She wrote this song.
Porque pensaba que el atrapado en la luna no me podía ver. Pero entendí que desde arriba guardar esas historias desde arriba, bien que velan.
5 seconds. 2, 1. Ew! Time's up. If you haven't finished it, if you are still typing, don't worry, just come up to us after the event. We will make sure that your ideal future will also make it to this time capsule. And to actually achieve the situation that we all put in this time capsule, we need innovations. And our first speaker has actually innovated with something really cool. Because in emergency situations and in war, there are two things that are very scarce: clean water and hygienic sanitations, so that you can use a bathroom, for example. And our next speaker has actually developed a solution where you can use the bathroom, but in the same container, it actually uses that waste, cleans it, and makes it into clean, drinkable water. And he has developed space technology to do this. How and what it is exactly, he will share with you today. Here to tell you all about it is the CEO of SEMiLLA Sanitation. Give a big round of applause for Peter Scheer.
Nice music to start with. Yeah. And need I say more? Actually, the introduction was the summary, so thank you all. You were a great audience, and I'll see you back at the network tables. Yeah, no, just kidding. It is more than what was introduced. My name is Peter Scheer. I worked with ESA for a year, and I get bored of only thinking of 6 people. Because in my heart I thought, with all the technology of ESA, you could do more and you can make impact into the world. So that's actually why I moved from 8 years ago from ESA as a vertical farmer. I become a SEMiLLA Sanitation entrepreneur to go into the deep shit of to being entrepreneur, to work with shit and all colors of water. Thank you for having me here. I hope that I can inspire you to make a better solution than I did. Because I did a lot, I fucked up a lot. It's not a word what proper is used, but sorry for that. But I fucked up, really. But it's the lessons learned, and we have to fuck up for the third time now. I stop with that. Let's make a party, let's make innovations. My name is Peter Scheer, I'm the CEO of SEMiLLA Sanitation. And SEMiLLA stands for? Yeah. And my slogan is, drop a seed on what you peed and you will never die. So keep that in mind, use urine, make food. Food challenge is ready. I am inspired in the year working at ESA at the MELISSA program. MELISSA stands for Microecological Life Support System Alternative. That's a nice acronym, but actually what is really necessary to know that the basic necessities for life are in your body. Pee, poo, and wash. Take all these streams and you can survive. And that I will show you with innovations what I did the last 8 years. Reuse, reduce, recover. That's our main topic. Water is reused for flushing water and irrigation water. Cost, water use, diseases and pollution are reduced. And irrigation water, fertilizers and compost are recovered. That's my sales pitch. But actually, it's not a pitch, it's there. It's not a sales, it's there. You have to use it. Because your body is full of fertilizers, and that's the base of our innovations. I hope to inspire you, but I'm inspired by André Kuipers, and actually you have to spread the word. So if you have an invention, talk about it, share your ideas, and you get feedback, and you will receive feedback if you ask it or not. And actually, to address P2T, it's disgusting if you think about it. Your brains are doing something with it, but actually it helped me to start a discussion with a lot of festival visitors, because we collect P and we make a cup of fresh mint tea. My first pickup was being an entrepreneur and being successful, and I didn't like it. So I want to make impact. I'm a horticulture specialist. I'm a vertical farm specialist, I'm a greenhouse specialist, and the last 8 years I became a water expert, because I believe in SDG 6 and SDG 2. With good sanitation and clean water and zero hunger, we can save the world. So that's actually what I want to do. So I decided to sell my company, and that's actually the news that since the 1st of January, I sold my company to a giant, and the giant is called Scheer Industries, and they will help me to implement my innovations all over the world. And that's really necessary, because I want to make impact. I don't want to be necessarily an entrepreneur, but I want to be an entrepreneurial way of working, thinking. And they can support me. They make wastewater clean all over the world, and they also help me start thinking of waste is no waste, but waste can be turned into really useful products to earn money, because the damn money always rules the world. So we have to earn money with our ideas, because then we can close the loop. Here's the time. Normally I talk for an hour, but no, only 50 minutes. So I will start. SEMiLLA program is actually based on your body. Your poo, pee and wash water is enough for 500 grams of fresh vegetables to grow. 12 grams of fertilizers in your body, in the poo and in the pee. If you look at separate at source, because the introduction was that I designed a container where you can poo, pee and wash yourself and collect it separately, and so you can treat it separately and you can clean it and reuse it easily. And that's actually what we try to do. The SEMiLLA program will have a self-sufficient Mars mission. Rocket engines can't carry all the food and water, so we need to be self-sufficient. That's the SEMiLLA concept, actually. 32 years already of research doing a self-sufficient Mars mission. But we can do the same, because I was inspired to think like an astronaut. And if you have a spaceship with 6 astronauts, you also can pretend we have you see the crew of a spaceship, but actually the world population are also astronauts, and we have to make sure that all the resources we get from Mother Earth, we turn it back to Mother Earth via food. Spaceship approach is actually what we try to do, and that's what we try to stimulate, to make circular and smart cities. So look at all the opportunities your waste gives you and make it possible. And actually my first idea was ever make fire out of your poo, because biogas is also farmed out of your shit, and you can cook your meal, you pee in a separate source device. You turn the phosphorus and the nitrogen into fresh food, you cook it, all available stuff just in your backyard to make a sustainable life, but also a circular life. So I will not talk too much about this sheet, but my dream is, my vision is to make a closed loop system for cities, even as we can do on the moon or Mars in the spaceships. Where do you start? I did 2 years of peeing in the morning as start. I collected in a bottle together with my researcher, and we looked at which diet gives us the best fertilizers. And actually McDonald's didn't do it that good, because If you look at your body, you have to, the food convention is conversion, I must say that McDonald's gives you a lot of nitrogen and phosphorus in your pee. So actually it's the best food for an astronaut because you have a good leftover, so you can produce a lot of food because a lot of nutrients are available. But I'm not having any shares in McDonald's, so I will not stop. I will stop now. I started actually with our own pee. We vacuum evaporated our pee, we made clean water, we need nutrients. Actually, ASA sponsored for us for a climate room, and we did a lot of research in just 2 small racks of vertical farms, and we gained a lot of experience in growing fresh basilicum and fresh mint. And actually, then we tried to look at the money side, and this was too expensive because it consumed a lot of energy. And there starts the thinking of think circular, because if you can make energy with your own body, then it's not that strange to think in a more closed loop, because then you can also closing your wallet. The next step was actually also that by incident you find bacteria also who can help you. So we started with just pure urine and vacuum evaporation, but after that we also find the bacteria what easily grows on pee and brewery water. So there was also a solution. If you have the purple bacteria, you can have the purple bacteria to help you clean the water, but also to make a biostimulant to grow food. So that inspired us. We did a lot of research with the Wageningen University and the best efficient methods available to grow food based on space technology. Then you are going to think bigger. So what we actually designed is a sanitation hub with a climate room. And we also designed a building for St. Martin. That was a few years ago, 8 years ago, what cities were blown away, villages were blown away, and we could make a bid book with a cleaning system, a water system, and a growing system, so you can be self-sufficient in one spaceship again. So that really inspires us, and we went going on to make sure that we have our ideal city at the end, that the skyscraper is for entertaining to play a part of golf at the rooftop, then do your recreation, your sports, your paddling, tennis, then you have your living, then you have your working, then you have your supermarket space and restaurants, and in the basement you have to have your wastewater treatment plants and your food production plants. So that's my ideal world again, so put it in the capsule. There you have 2 from my side. To dream is nice, but to make it happen, that's actually the main goal in my life. I'm actually a practical guy. I didn't make it in Wageningen University, only applied science university. That was my highest possibility, but I learned a lot by doing with my hands and to just do it. So, and that's also, I want to inspire you all, just do it. Don't overthink too much, because then you kill your own plan in the first 3 feedback sessions. So start doing it, learn from your failures, and move on. Because that helped me in 8 years to be successful, and that also a company wants to buy you, because you can sell something, but if there's no buyer, there's nothing. So this is what we did actually, a toilet unit with a stratified reactor to make ammonium phosphate, and also a growing rack to show that we can make fresh mint tea out of pee, because that was what we did. We collect urine, we make drinking water, we make fertilizers, and we make fresh mint for tea. I don't know how long I have, 2 minutes, 3 minutes, yeah? This is actually a nice picture where I already explained that on your pee only daily, 1 pee of 200, just 1 glass of beer, you pee it, you donate it to the system, you can make 25 cups of fresh mint tea. That's amazing. This is the tea. And I'm most proud of what I do in refugee camps in developing countries, because in heart I want to be the entrepreneur who converts space technology into innovations for those who need it the most. And we are now working in a refugee settlement in Mvepi in Uganda, where we collect the poo, we make biogas, we make compost, we make irrigation water, and we make trees. Trees, fruit trees, construction wood, and restore nature trees. We collect approximately from 25,000 people the poo. We make approximately for 2,500 people biogas, and we create forests, and we are re-greening the area. And I think that's how we should do it, because also it's economically feasible. And therefore also the development will grow. So if you look at the Sustainable Development Goals Caroline was mentioning, I think 16 of the 17 we are working on, and that's amazing, I think. Yeah. This is a situation, and also we want to work together with the locals. So these are refugees, and we are making the best possible. But also in the Netherlands, we are creating now new steps into scaling up. We have a really big urine treatment facility ready to convert 5,000 liters of urine per day. So we need a lot of donations the next coming years at SEMiLLA, at... oh no, this is one picture I want to explain of the refugee camp, sorry. And then I will go to SEMiLLA. This is actually the loop, because by looking at the spaceship, we created this loop. Because actually you eat, you shit, the shit will become fire, fertilizers and food. And if you have food, yeah, you get to shit again. So this never-ending story, so that's good to inspire you. Then what we are going to do next year, we really want to engage people to make sure that they donate every possible urine drop to make it into fertilizers. And we start in the city of Amsterdam, where we are going to treat 6 million liters of urine yearly. And you can count out how much food we could produce, because actually we also can supply the food for the whole city of Amsterdam. So that is closing the loop. So please go to festivals, donate your urine, then you make me happy. And of course, I wanted to be here because we need a lot of water experts. So be a water champion. We are looking for you. So if you don't want to start up your own company, start something up in our company, because there's place enough for good ideas and for good impact. Scan the button. Thank you.
Wow. So we really need to go to festivals and shit a lot.
Yeah.
Yes.
And
Okay.
urine a lot, because
And
we
urine a lot.
separate at source.
Okay, cool. So I can imagine that people here in the audience might have a question for you. So I already see a hand going up. Are you a good thrower?
No.
Oh, me neither. So beware, Caroline. Oh,
Quite okay.
was okay, yeah? So that's a catch box, and you can talk in the catch box, and then everyone can hear you. Cool, right? Hi.
I hope it works. Yeah.
What is your name?
My name is Ilse.
Hi, Ilse.
I was
Closer to your mouth, please. Yes.
like this.
Yeah, a little bit, yeah.
Eat it.
Almost eat it. Yeah.
I was wondering, how do you deal with micropollutants like medicine remainings or that?
Drugs from
Yeah.
the festivals.
Well, yeah.
Or not.
I try to find a business model out of it. So if I can recover it, then I can make new drugs again. But that's not possible yet. No, just joking. That's a big problem. And the first ideas we always had some pollution in the fertilizer. But now we have a sort of stripping technology. And the first one, the stratified reactor, also worked well. We did with the University of Amsterdam, we did research. And actually there's no connection between the fertilizer we produce and the pollution that we have in the water. That's the fertilizer side. If you go to the drinking water side, there we designed with also NX filtration more membranes, what can make sure that the pollution is out of the water. You lose 20% of the water, but then still 80% is available. Yeah.
Okay, so there is a solution.
Yeah.
You have found a solution.
Yeah, but the best solution is don't take it, don't put it in the water. And if you put it in the water, donated via the urine, because that's really nice of your body. I didn't know it a year ago, but our body is designed with a poo in front and a poo in the back and pee in the front. So I didn't know why, but now I know why we have to catch the urine separately from the poo.
Okay. Next question. Does anyone else have a question?
Don't dare anymore.
No. So, yeah, there's one hand going up. Frank, you look like a very good thrower. Oh, you're bringing it to him. No, it's a catch box. You can throw it.
Talk in the poo hole here.
Yeah. Okay, can you stand up, please?
Yes.
So we can see you. Yes. What's your name?
Hello, I'm George Truijen.
Hi, George.
Hi.
Welcome. What is your question for Peter?
My question is about the customer. So normally when you have a business proposition, you need to know, like, is there a customer for me? So who was the customer for the PT?
The PT was just a gimmick, because we wanted to know if the customer would drink it. And actually, by seeing the machine, 80% of the customers would drink it. So therefore, we could start the discussion about circular approach, and that helped us. But the next question is there a customer now for the products we are producing? And yes, the fertilizer, we have to export it to Germany and France, because the legislation in the Netherlands is still poor. But we are working on a new legislation in the Netherlands also, that the pea fertilizer is well recognized and also legal in the Netherlands. So that's where we're working on, but it's close by.
Similar problem to the animal pee.
Sorry?
Similar problem to the animal pee for fertilizer.
Yeah.
Okay.
Oh,
thank you.
He knows his stuff.
Yeah, I know.
Yeah.
That's why I say yes.
Yes, you can throw it back. Oh, yeah, go for it.
We have a help.
Yes.
Yeah.
Well thrown. Okay. Any other questions? Yeah, for you. Yeah, good one.
Oh, I was just wondering, how did you turn this poo into natural gas? And because I looked into the trash to gas experiment.
It's so a little bit.
The trash to gas experiment in NASA. Are you inspired by that, or?
Yeah, and actually it's all about, and that's where we are bringing in new technology, because it should be fresh. And if you store it for a while, your potential gas is gone already. So we have to mix it with other organic materials to make it more efficient. And there we go to the animal discussion again. The animal poo is more into methane gas than the human poo. So we have to mix to make the best out of it. But it's possible, and yes, I'm inspired. While any innovation, what we think of, is inspired by the ESA and the space technology. Nice. Yeah.
Okay, cool. Thank you. You can throw it back. Ooh. Any other questions that they have for you? Yeah, you can. Will you stay for the networking drinks?
Of
a little
course.
bit?
Yeah.
Yes. Okay. Then you can post them at the networking
We
drinks.
serve fresh mint tea.
Yes.
For those who like.
Perfect, perfect. And one thing, I was wondering if there are students inspired by this challenge and think, oh, I really want to work for Peter. Is that possible?
Yeah.
Yeah?
Yeah.
Okay, so then they also know.
At least 4 or 5 we need.
Well, now you know. Can I get a big round of applause for Peter? Okay, so I've noticed that you already know a lot. Is this the same as for animals, or is it different? So you already know a lot of things. But let's see how far your knowledge already goes while we get to know even more people. Ah, how cool is that? We will now do a little quiz with some questions about what you already know. So what I would like you to do here in the audience is form a group of 4 or 5 people, preferably with people you don't know, maybe mix it up a little bit with people working for the university, people from one of the partner organizations, students. Try to form a group of 4 or 5 people. And the people watching at home, you can also participate. If you have a group around you at home or just by yourself, then you are your own group. So first, just form a group of 4 or 5 people. 3, 2, 1, go! Yes! You can mingle. Groups are formed. Okay. Who doesn't have a group yet? Please raise your hand. If you are not in a group. Okay, if you are not in a group, please raise your hand. Yes, there's one. Are you in a group? Okay. Everyone is in a group? Okay. What we will do now is for you at home, you will see the Mentimeter also on your screen. So you can participate. For the rest of the groups, hear me out. One person per group, get out your phone. One person per group, get out your phone and scan the Mentimeter. This is a new code, so not the same code as before. Yes? And first you will probably see that you have to enter a name. If you win, that name will be on the screen. You can call it poop and shit, that's fine by me, but just know that it's on the screen. Yes? Okay, so is everyone in? Yes? Is it working? Someone has to press a button again? You have 10 people in, so there are 10 people in. So we can continue. Who is not in? No? Not in yet? Why is that? I'm just looking at the technology here. Okay. If not, if it doesn't succeed with one phone, maybe one of your other group members can get the phone. I see a thumbs up. You are all in. Okay, we are going to start. So first, I would like to ask someone on stage who actually knows the answer to all of these questions. So before we start, can I get a big round of applause for Wieger Wamelink? Applause! Okay. All right. So Wieger, you have actually been growing plants on Mars and Moon, or you've shown that it's possible, right?
Yeah, there's a slight difference between doing it at Mars and Moon and what we're doing here on in the campus.
Yes.
But yes, we use regular simulants for Moon and Mars to grow the crops. And for instance, we are recycling pee and poo as well, our own. And that's clean, I can tell you.
Okay, so, but you have done a lot of research on the soil here on Earth. So
Yes.
the soil from there, you use it here for the research.
Yes.
So you know a lot about it. Okay.
I hope.
So, yes. Okay, so we have a lot of players in here. We see it on the screen. That's you. Well, let's just start with answering the questions. So per group, you have 30 seconds to answer each question. Know that we will score you on if you get the answer right and how quickly you answer. That determines whether or not you will win. Are you ready for the first question? 3, 2, 1, go! Which kitchen appliance inspired by technology developed for space missions is now commonly used for quick and efficient cooking in households? Is it the microwave, the induction cooktop, the convection oven, or the slow cooker? What do you think? Answer as quickly as you can. 8 seconds left. If you haven't answered the question yet, do it quickly. 1 and go. Oh, the microwave. Okay, so you already know. Quickly, Wieger, the microwave?
Yeah, well, it's very handy if you want to have something warm to eat. And of course, cooking in space is a bit of a problem. You can't have fire. NASA is very scared of fire in space. And also water is a problem because you get corrosion. So then a microwave is the ideal solution, especially invented for the ISS.
Yes.
Before that Skylab.
Oh, and now here in all of our homes. Or I think most people have a microwave. Okay, let's go to the next question. There's a leaderboard. What are the main considerations for selecting crops to be grown in space? Is it The size of the crop, the color and water consumption? Is it the nutrient density, short growth cycle, and adaptability to harsh conditions? Is it the height of the crop and the amount of sunlight required? Or D, is it the taste and resistance to pests? Ooh, what do you think? Discuss this amongst each other. What do you think is the right answer? Type it in quickly. Yes, time's up. Okay. Yeah, 32 teams actually got this one right. Wieger, why is this the right answer?
Well, growing crops in space is hard. So you want to have as good as possible harvest, as quick as possible, with lots of nutrients that you need in those crops. So that's important. But other things are also important. For instance, taste. Ask André Kuipers. He was always very happy when a new Soyuz arrived with fresh food. Because that's much better than, well, the stuff from the microwave. So that's also important. But for us, efficiency is very, very important because the circumstances are so harsh. So that's why it's B.
That's why it's B.
But it's not the only thing.
It's not the only thing, but that's the answer. Okay, let's go to the next question. Which preservation method, refined for space travel, is now commonly used to extend the shelf life of various foods on Earth? Is it canning, freeze-drying, pickling, or fermentation? Oh, I see pickling twice. Well, then you have twice as much chance to get it right, huh?
Or wrong.
Or wrong. Yeah. I'm sure 3, 2, 1. Yep. That was it. Well, most people thought freeze drying, and that is also the correct answer. Can you tell us a little bit about it?
If you want to have something to eat in the space station, I already said it, it has to go up. There is a little bit of crop growth nowadays. It's called veggie, where they mostly grow salads, which I do not really understand because I want my potatoes. But if you have to ship it up, a lot of our food is, of course, water. You don't want to ship that up. You can recycle that. That's something we already heard. So you only bring the dry matter, and then you can, you have to freeze dry it, and then you can re-water it when you're on the ISS. That's most efficient.
Really cool. Didn't know that. Thank you. Let's go to the next question. Question number 4. Oh, leaderboard. Let's see which teams are actually... Ooh, Top Tayo. You are leading. Is Top Tayo here in the room or at home? Ooh. But still, I don't see a lot of differences. So everything is still possible. We still have 4 questions to go. Let's go. Question number 4. How can altered gravity affect plant growth and development? A. It enhances plant growth by increasing nutrient absorption. B. It has no effect on plant growth. C. It can alter root orientation and cell signaling. Or D. It makes plants grow larger than on Earth.
She's headed for the lights, but she sees the vision more.
10 seconds.
See how she looks for trouble. See how she dances in.
All right. Woo. So there are really smart people here in the room because still
a lot of good answers.
A lot of good answers. Please, why is it answer C?
Well, that's really interesting because this is something we learned in space. Plants here can feel, as it is, gravity. And then they know in which direction to send their roots and in which direction they send their stem. But if there is no gravity, then the plant is lost. So when they did this first in space, they put a seed in thin air, and then they watered it, and it grew leaves and roots through each other. So it was a very strange plant. But what we learned then as well is that sunlight also helps, because a plant is also phototropic. So if you put a bulb on top of it, it knows, okay, that's up, I have to send my stems and my leaves in that direction and the roots in the other direction. And you can understand, you can never test that here on Earth. So that was found out in Skylab.
Cool. Whoa, really cool. Okay, question number 5. Only 3 more to go. What is the in situ research utilization, ISRU, and how can it benefit future farming systems on the surface of the Moon and Mars? Is it A, it refers to producing resources on Earth before traveling to space? B, it involves using local resources? C, it requires sending robots to build farms in advance? Or D, it refers to using alien technology to grow plants in space? Woo! Be quick! Be quick! What do you think it is? Talk it over. 3, 2, 1. Yo! Oh, and again, 28 groups got it right. Yes. All right. Briefly, why does this involve local resources?
What we want on Mars and also on the Moon is to create a sustainable agricultural ecosystem. I'm not only a plant breeder, but I'm also an ecologist, and that's very handy to design something like this. And we already said it has to be sustainable, circular, and then you want to use as much resources that are available on the Moon and on Mars as well.
All right.
That's the reason why we do this.
It has to be circular.
Yes, it has to be circular.
All right.
Because
Next.
there's nothing there.
Next question. Question number 6. What type of food packaging developed to meet the needs of astronauts has influenced modern convenience food packaging? Is it vacuum-sealed pouches, glass jars, tin cans, or cardboard boxes? Five seconds. 4, 3, 2, 1. Yep. Again. A lot of people got this right. Short answer. Why is this? Why did they all get it right? Because I think almost all teams knew.
Weight.
Yeah, that's a very short answer, but it's true. Let's go to the final question. What is the correct order of the planets in our solar system starting from the sun? Ooh, starting from the sun.
Long time I broke the chains. I tried to fly a wild so high, direction sky. I tried to fly a wild so high, direction sky.
5 seconds. 4, 3, 2, 1, go. Yeah. Oh, maybe you got it wrong or right. So this is the correct order. And there was actually, did anyone notice there was one planet, or maybe missing or not missing? Yes, why?
Well, Pluto used to be a planet, but it was revised and it was skipped from the list of the planets. It's now a dwarf planet, planet-wide. Yeah. But some people do not agree. Yeah. I do not agree.
Oh, you do not agree. Okay.
So, and they're still discussing it.
Okay, during the network drinks, they can discuss this with you.
But I'm very happy to see that most people can find their way in the solar system.
All right.
You won't get lost.
Are you ready to hear who the winner of the quiz is? The winner of the quiz is...
Okay.
Oh, switch. Davi! Are they here? Raise your hand if you're Davi. No. Are you? Maybe you are watching at home. You will still get a prize. Just email it to studentchallenges@word.nl. Oh, you are here. Oh, you're second place. You will get the prize. We will send it over to you. But the group, second place, you can come over. Come here on stage. Yeah. Can I get a big round of applause for Wieger? This is our winning team. Okay. Maybe you can, yeah. Come over here. Yeah. All right. Perfect. Big round of applause. The rest of you can take a seat. Yes. Okay. Just a quick question so that we know who these space enthusiasts are that already know a lot about space farming. What is your name?
I'm Leah.
I'm Rafael.
I'm Maitri.
Fuyuki.
Morgan.
Oh, cool. And how come you already know so much about this?
I don't know.
You don't know. Do you know?
No.
Do you know? No?
I read a lot of sci-fi.
So that's actually the thing. So it lets you think outside of the box of what is possible, I think, or not?
Yeah, I mean, a lot of it is hard sci-fi, so it's based on real science.
Oh, it's based on real science. Oh, that's also possible. I didn't know. I thought about Star Wars, but that's a different category, I think. Okay. Okay, well, we actually have a prize for you. Can you hold this for me? Yes. Oh. So, in the Netherlands, we have a very great tradition, is that you put this on your toilet. It's a calendar. So, I would like to give... Here you go. Here you go. There you go. Can I get a big round of applause for the winners of the challenge? At least the ones here. Thank you. Okay, so already a lot of knowledge here in the room. And our next speaker actually knows that there's no food that we can just pick up and eat at Mars when we are there. So when astronauts are exploring space, they cannot just fry an egg. So food is a crucial part of the exploration. But after years of improving formulated products for astronauts, we are entering a new phase of space exploration. So since 2014, food has been successfully grown on the International Space Station, and we can expect new breakthroughs in the coming years. Our next speaker will tell you all about it. Give it up for European Space Agency engineer Christel Paille. I will fix that, don't worry.
Shall I let it on the ground?
Sorry, what was it? Yeah? Oh, shall I pick it up for you? Don't worry.
No, that's not the point. I was just wondering. I arrived late, I had a few troubles so to come here. So my name is Christel Paille. I work as an environmental control and life support system engineer in the European Space Agency. And my role is two things. The first thing is globally environmental control and life support system. So we look at a lot of different technologies. And the other one is project engineer for the SEMiLLA project, which I will say a couple of words. How do I get the slides running?
Yes.
This one?
Yep.
Okay. So we start with a little bit of an overview of what, let's say, a space food system would be. At least the main aspects that are talked about by any, let's say, space engineer so far. And when we look a little bit at the details, we see mainly three big categories. One is the system level, which is referring to all the different standards that we are using, and the cooperation agreements, the, let's say, interoperability of the system, etc., etc. The second one is at the technology level, so it's really hardware, it's design, it's what we call the reliability, all the safety issues, but which are machine-oriented. And then the third level is, of course, the human being. So what refers to, let's say, the nutrition, the palatability, the acceptance by a crew member. All right? So far, I think you understood it from the quiz that Wieger established. The food is mainly uploaded to the International Space Station by a cargo vehicle. And very little is actually produced on board. And what is produced on board, Wieger said it, it's a little bit of leafy vegetables, which are considered today as experimental, much more than operational, and much more than really having a nutritional value. So, a few details on the fact that this system today is what we call an engineer system, in the sense that it has a target of 3,000 kilocalories delivered per person and per day, with variability. So all is based on logistics support, and indeed, based on certain scientific studies that we have performed, what we see today is that as long as we are, let's say, in low Earth orbit, so in the vicinity 400 kilometers around the Earth, the logistics helps to maintain a nutritional level, a health and well-being of the astronaut. Now, when we go further and we decrease this level of the logistics, then we enter into a problematic which is nutrition oriented and which is, let's say, risking the well-being and the health of the astronaut. And that's one of the reasons, the main reason why we are looking for alternative for in-situ food production or, let's say, alternative preservation method. But in the present case, we'll look at in-situ food production. So that has been, let's say, it's part of the critical technologies which have been identified at the international level. So all the space agencies everywhere in the world come to a consensus that food is actually critical. That's a system on which we need to work. Now, the point is that there is already an existing system which is based on shelf food. And we need to combine both. From the studies, again, that we have conducted, we can't replace one by another, but we need to combine both, at least for the near future, for the mission, for the moon, etc., etc. Now, on board production, I won't teach you anything because you're all from that part of activities. But basically, when we produce food, we produce living organisms. That's what we need to produce food. And there are several categories. On the agency side, where we are the most advanced are on cyanobacteria and crops. But we are also working on, let's say, system based on animal cells, on yeast, let's say fungi, mushrooms, and alternative bacteria. So the point is that here again, when we are in a closed system, because that's what a space vehicle is, in a closed system, when we introduce an organism, an additional organism that we produce, we need a certain number of resources, but it also comes with a certain number of modification or, let's say, addition to other functions. Like, for instance, if you take a cyanobacteria and you grow in there, you will absorb the CO2, you will produce the oxygen, and you produce biomass. but you also need a certain number of minerals to grow it, and additional energy system. So all that, let's say, is important when we look basically at the full closure of the system, which in Europe we use the SEMiLLA project, which exists since 1987 or 89, something like that, and plan basically full closure on the materials, so carbon cycling and nitrogen cycling inside the space vehicle. It's based basically on the main processes of matter cycling which are existing on Earth, on the aquatic lake. And we just, let's say, engineered a little bit that system. So for the sake of the presentation, I will focus on the crop part, but everything that I will present, actually we have the parallel on cyanobacteria in terms of maturity. So just here, it's just mentioning, let's say, the contribution that the crop production stage in a closed system would provide. And on our side, based on a certain number of requirements that we use for the development of space technology, we need to enter into a certain number of details, and notably the dynamic and the molecular level of what the plant does. Our aim here is to couple basically what we call the energetic balance and the mass balance of the plant, and validate that in a certain number of environments. That's one of the main scientific challenges, the biggest we are facing, actually. On the technology side, well, it's to come with a system which is designed with a certain number of peculiarities. You remember what I showed about the space food system. So the same, but here a little bit, let's say, complemented because it includes a human being, and optimized with regards to a certain number of criteria, which are the mass of the technology to be uploaded, the space it will take, so the volume, the energy it will consume, and the number of hours that it takes for a human being to actually operate it. Plus other. So generally speaking, our approach is to go from fundamental research, so we have a lot of R&D activities, and then we have two streams. One is really for everything that is, let's say, related to space at the scientific level and at the technology demonstration level, and another path which is on ground and which is looking at the integration on ground of the SEMiLLA system, of the closed loop. So with regards to the crop, here again, most of the activities that we do have, which are producing the baseline data at the scientific level, are performed in the University of Naples, in a facility that we built especially for that, and which was delivered in 2019. Well, there are a certain number of papers. In terms of scientific space activities, well, there is a lot of knowledge which is already available. One of them, or let's say a lot of the work which was performed, was indeed looking at the root development. Not so much until more than 2014, because it came with the advanced plant habitat, where we can actually study the full crop development. And what comes, let's say, on our side is one level further, at the level of the exchanges, the gas exchanges at the leaf level, and especially what concerns the resistance of these exchanges due to the boundary layer. Here again, it's a phenomenon that we cannot observe on Earth, and we need the microgravity to study it. Now, in terms of integrated demonstration, we have a pilot site in the University Autónoma of Barcelona in Spain, where we do have a certain number of technology which allows us to combine those different levels to reconstruct the cycle and close the matter. So one of the tests that we performed, let's say, rather recently, or we completed, was the coupling of an animal compartment and a crop-producing compartment to create a closed loop at the gas level, so really to close the oxygen-carbon recycling loop. I won't enter into the description of the data, the graph that you have there. One of the conclusions was that, well, first of all, it is possible actually to guarantee a closed cycle between the two without having either deleterious effect on the crop or harmful effect on the animal, which is already an achievement in a completely closed loop. And the fact that we could maintain actually the set point in terms of oxygen percentage and CO2 percentage in the animal compartment in a dynamic manner. So that's also very important, because your human being in space, it will have its metabolism, which is dynamic, and of course you need a system which follows that. Yeah? All right. Then now we leave the, let's say, the ground floor and go towards the space demonstration. One of our, let's say, major development is what we call the food production, the precursor to food production unit. It's at the level of the breadboard today. It's a small, let's say, box. Here you can see we did test on lettuces and potatoes. So basically you have only 2 crops, but it's, let's say, a demonstrator. It's not yet a fully blown and operational system. And this one normally should fly either towards the end of the space station, so 2030, or together with the Axiom station, so slightly after. Depends on how quick we can do the verification, but with plants we cannot be so quick, and we depend also on them. So, and the space operational concept, system concept, to do exactly the same thing. You have seen in the breadboard we had 2 plants. Here we have, basically we plan to have other type of plants and in bigger quantity, so there is a little bit more space. Yeah. And now I was talking in the introduction the level of the human acceptance. So there are different tests that can be performed, but the first one of them, which is very well known for anybody who is working on space food actually, is the rhythm at which you can repeat the consumption of that recipe, because it influences very much the level of acceptance, let's say the mood and the performance overall of the crew once it is in the space and in operation. That creates, let's say, a kind of a stress and monotony. So that's the kind of thing that we test on, let's say, selected recipes. And usually we test it in, let's say, an environment which is close, analog to, let's say, space stress environment. So here it's bed rest. And then we do also on board, let's say, study of crew perception. We ask the crew to consume actually a certain product and give back, fill in a questionnaire. So we get, let's say, an evaluation or a feeling of how the recipe, the testing and the feeling of the recipe changes compared to ground, right? Now, just a very quick conclusion. From the R&D side, well, we'll go at the pace that we can go. Studies on plants oblige. And we are, let's say, bound to the kinetic of growth of those organisms. But it's, let's say, progressing. So more hands are always, let's say, welcome. In terms of integrating demonstration, let's say we also are progressing quite fast. The only thing that is probably missing, and we will see then afterwards, is on the part of the food processing, so meaning once we have produced either our cyanobacteria, either our bacteria, our animal cells or whatever, well, there is a need a little bit of processing to come up with a product which is like a recipe or a dish. And the instrumentation is very, very poor at the moment. It's limited to that won't help too much for eating. And the other side is, of course, well, the waste production. So when we produce a plant, there is a little bit of a waste. We are looking at a plethora you depending on the type of mission, so depending on the destination, but it's not possible for all of them. And then and look at the full chain, you are very well aware of the complexity actually at the interdisciplinary level that exists in this. Let's say outside, I would say, of the standard work, and that's yet to be approached in the proper way. Yeah? So overall, I would say in conclusion, although results are good up to now, we are always welcoming new scientists and new people with ideas of new technology, new project, new application, and so more creativity overall. Voilà, thank you. I will just, yeah. Go on.
Thank you. All right. Okay, cool.
Yeah, that was
a question for her. I have a question. I saw some people taking pictures. Can you share the slides? Yeah, they were taking pictures of the slides, so a very practical question.
You can,
you can answer. Yeah.
You can get the slides, no problem.
Perfect. I saw a question over there. Here it is. Woo!
Hello, my name is Marijn. I'm from BO Akkerbouw. If you have the possibility, let's say for breeding techniques, that everything was possible, what would be the first feature of a plant or any organism that you would change?
Oh, yes. What would be the first?
You mean in terms of physical feature? Physical feature would probably be the size, the height. Although, yeah?
Sorry,
you didn't hear me?
Throw it in your face, but otherwise we cannot understand you.
Okay, no problem. So I repeat. Yeah, the first physical feature is actually the height. Because I think, yeah, Wieger mentioned the part on the nutrients and so on. The major constraint that we do have is actually the volume and the space which is needed for the crop today. And the shorter, then the smaller the volume. In principle, if you keep an equilibrium with the roots better.
Okay. Clear question, clear answer. Final question. Anyone have a question? I think you, oh, yeah, one. Okay, you can stand up. I'll do my best. Woo! Okay. What is your name and what is your question? You can hold it up like this.
Yeah.
Yes.
Hi, I'm Carlos from KWS. I have two questions. First one.
You can have one. Yeah.
What is more efficient? Going for the growth of plants or cyanobacteria, your scenario number one, or growing yeasts or microbes to produce the food we need?
Clear? Yep. Thank you.
I can answer only partially because we don't have our numbers at the same, let's say, level of maturity for all the different solutions. So the partial answer is it really much depends on all the resources that needs to be taken for each and every solution and how well it can be integrated in the rest of the loop. So there's a question of, let's say, efficiency of production, but also a lot of interfaces with the rest of the system.
Okay, clear. Will you stay for the drinks?
Yeah.
Okay, so if you have a question, they can just walk up to you. Yes, you can post it during the networking drinks. Yes, perfect. Well, for you, there's nothing left than for us as an audience to thank you for sharing all of your knowledge with us. Can I have a big round of applause for Christel Paille? Okay, so this is a student challenge, and the students already have got some kind of an idea or a concept that they will be working on, testing, putting into practice, like Peter said, just go. So, and a few of these students have actually said, well, I'll share this up front with this audience, but if they are so cool to actually do that, just before the start of the challenge, we need to make sure that as an audience we can give them, all of our muscles are really loose, that we can give them the best applause that we can give them, right? Yes, so I have a small challenge for you as well as an audience, so that you will be the best audience ever. So I would like you all to stand up. Yes. And you will hear this music. Yes, you're already starting to clap. That's great. Okay, there's a little catch. So when you hear this music and you see a moon on the screen, oh God, you will do this. Yay! 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 That's it. Can we practice? The moon is on? Okay, music. Yay! 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 Yeah, you got it, you got it. Okay. Now that you see a different image, ooh, there's a twist. You see the earth. You will do this. Ha! And you will give a high five to your neighbor. Yeah? Okay, so boom, boom, high five. Boom, boom, high five. Let's practice. Music, please. Boom, boom, high five. Boom, boom, high five. Boom, boom, high five. Boom. And if you don't have anyone, you can also do it with the 3 people, like this. Yeah, turn around, turn around. Boom, boom, high five. Yeah, you're doing a great job. Okay, here's the challenge. You will now see the images on the screen, but we don't know which one will come up. So we know yay is when we see the moon, and high five is when we see the earth. Okay, are you ready? Music, please. Yeah, earth. Hey. Hey. Hey, our earth. Again, earth. Yes, earth. Whoa. Boom, boom, yay. Boom, boom, yay. Boom, boom, hey. Oh, boom, boom, yay. Boom, boom, clap. Boom, boom, clap. Boom, boom, yay. Boom, boom, yay. Boom, boom, yay. Boom, boom, yay. Boom, boom, clap. Boom, boom, clap. Boom, boom, clap. Boom, boom, hey. Oh, boom, boom, yay. Boom, boom, yay. Boom, boom, yay. Okay, are you all? Oh. Boom, boom, clap. Clap. Boom, boom, hey. Boom, boom, yay. Okay, I think you are all warmed up, right? All the muscles are warmed up. Let's see if you can give a good applause now. Yeah, woo! Yeah, I think so, yes. You can all take a seat, because then you will see pictures. 3. And I will invite to the stage the plant science student here from Wageningen University, from Team Hub. It is Marcus Mortensen. Marcus! It's not Marcus, I think. What is your name?
Morgan Timmy. Hello.
Morgan Timmy. Big round of applause for Morgan Timmy! You have 1 minute. When you hear the music,
Hello, everyone. Let me ask you, have you ever come back from holiday and killed all your plants? Have you ever killed all your plants from overwatering? Have your kids or pets ever made a mess from the soil in your flower pots? Well, the HAB introduces astrogel-based indoor farming products that make sustainable food production accessible and engaging for urban households. These low-cost, reusable systems are safe and clean for in-home use, and are even food-grade and edible, making them perfect for kids and families. Hydrogel is a growth medium developed for plant growth in outer space in the International Space Station. Our astrogels are enhanced so that they are all natural, fully biodegradable, and reusable. They retain water and nutrients so no watering is needed. Astrogel systems can be used for a small scale, such as a home herb garden, a medium scale, like a community space or a store. Bark like an astronaut.
Big round of applause. Oh, you know, maybe it sounds a little bit harsh, but this is actually part of this challenge. Because when you have an innovation, you need to tell it to so many people, and you need to be able to do it in a concise way. So, next picture from Team VIP Protons, a food technology student, Zenyuan Q.
Hello?
Yes.
Okay, before we introduce our idea, I will highlight two challenges to you guys. First is humans generate a lot of waste, especially food. In 2022, we generate 1 billion tons of the food waste. The second is the calling for searching for sustainable protein, because now the population is growing, and we want to feed these populations without provides extra negative impact for the food for the environment. So, how to solve these two challenges? Our idea is to create a recycle system in the front of the garbage bin. We will use a special microorganism to extract the nutrition from the food waste and use this nutrition to grow a protein-dense microalgae. And this recycle system you can use at home or in space. So our version is, with this recycle system, everybody can claim their own sustainable protein.
Well done! Oh, what I loved is that she was like, oh, wait, where was I? And then she was like, oh, I remember again. And then she just continued. Oh, I love it. I love it when that happens. Okay, then we have one more team here in the room that's going to pitch today. And that is Team Cyanotreats. And it consists of students of biotechnology and food at Wageningen University. And who is going to pitch from your team? Can I get a big round of applause? To two. Okay, then you can change the mics.
Yes, thank you. Yes. Okay, imagine that we can turn something that we consider to be waste into a sustainable food solution. At Cyanotreats, we are rethinking protein production by using human urine. Yes, again, the urine. Because did you know that every day each person flushes away 1.4 liters of urine that still has valuable components? By using these components, we can grow cyanobacteria and create an alternative protein source, all while aiming for a zero waste and climate-independent production system, all from something that's already being wasted every day.
And it does not stop with just creating another alternative resource of protein. I'm hungry right now, and I can imagine already crunchy, maybe protein bar, and nutrient-rich smoothie powder, or a sustainable supplement, all made from human wastewater. Join us in transforming our wasteful resource into a wasteless food product for Earth and beyond.
Good job, good job. All right. Good job, everyone. So we have one team left that's going to pitch, and it's not going to be in this room, someone online. Calling in from Milano. Hello, you can wave. Hello, can you hear me?
Hi.
Hi,
Yes,
hi.
I
We
can
can
hear you.
also hear you. We can also hear you. Paolo
Yeah.
Viviani.
Yeah.
Okay.
We are from the team Microtia,
Okay. Yes.
dedicated to an. Oh, you want to do the picture or?
So on my cue, you can start. So you are from Team Micro T, and here is your 1 minute of fame. Your moment to shine. Can I have a big round of applause for Paolo?
Thank you. We are a team Microtia dedicated to enhance the yield and potential of microorganisms and plants through an innovative tool, microfluidics. This technology offers a faster and more efficient way to select and detect microorganisms and plant cells. By utilizing mechanical selection and deformation, microfluidics present an innovative approach to harnessing the potential of CRISPR-Cas9 technology. The growing demand for microorganisms and cell selection in the food sector provides us a unique opportunity to fund our work. This support will strengthen our R&D efforts, enabling us to advance and prioritize our main project, increasing the product yield of microorganisms and plants. This improvement aims to address the pressing needs for alternative protein sources in Europe and meet increasing food demands worldwide. Thank you.
Thank you, Paolo. Thank you. All right. Well, you are participating in this challenge, and of course there will be a jury that's actually going to see what you have been working on. And we are now going to meet 2 jury members, and they are actually going to help us launch this challenge. Can I please get on stage? She works at Shift Invest, that's a venture capital fund, and she assists companies that really want to contribute to climate change. Can I get a big round of applause for Sophie van Wede? All right. And he works, the next jury member works at Division Q, and he works on innovations for the greenhouse horticulture sector. If you have to say that every day, that's really a difficult sentence. But anyway, he works there and he works really hard on these innovations. Can I get a big round of applause for Bart van Meurs? All right. Thank you, Frank. So, you are working on these innovations all day. When looking at this challenge, what do you hope to see at the end of the challenge? So we have just seen the beginning, but what do you hope to see at the end?
Well, to be honest, I'm already very impressed by the groups that have already been pitching, given that this is only the kickoff.
Yes.
I can only imagine with what you come up with. What I hope to see is also kind of the elegance of simplicity. So some of the best solutions to the problems we have in this world, whether it's in medicine or in climate, are actually quite simple solutions. So definitely try to think outside the box, but don't make it too complicated.
Yes, and keep it simple. Do you also look at the business perspective more because you work at a VC
I do,
fund?
yes. So somebody in the audience already mentioned the customer. You're only going to make impact if you're going to be able to sell your solution. So you can be a very impactful technical innovation, but if nobody is going to buy it, there's no impact. So definitely something to watch for.
Definitely. And what is it for you, Bart? What would you like to see at the end of the challenge?
I think we have challenges enough here on Earth in agriculture and horticulture. And looking from a bit of distance, from space, from Mars or whatever, can bring new insights that we can also use here. So I'm also looking at the practical usability here on Earth.
All right, so technological innovations, it has to be for the business. It has to be valuable in business. And also this, yes, true.
A bit out of this world, please.
A bit out of this world, so you can also think a little bit out of the box. Yes, all right. And what do they have to do to win?
Well, if I tell that now, that's like giving the answer. No, no. I think really addressing the different characteristics of what's happening in space. So obviously, no solution is perfect, but trying to address as many of the the issues out there goes a long way.
Yeah, okay. And I've also sometimes heard that for every idea, for every innovation or idea, that there can be something that is good, but that there's also something that's not good. Should they share that with the jury, that they think, oh, maybe we think it's a solution, but maybe not?
Yes, please.
Okay.
I heard the term fuck up already. Thanks for that. But you need to fall down, you need to tickle over to stand up again and succeed. So yeah, please share.
Please share. So don't, if you fuck up, don't worry. Just share it with the jury and you'll be fine. Okay, are you ready to launch?
Definitely.
Okay, so we are now going to officially open the challenge. And of course we need the audience, you, again for this. So we are going to count down from 10 to 1. And then at 1, they will press this button and a movie will start to play. And then the challenge is officially kicked off. Are you ready? All right, 10, 9, 8, louder, 6, 5, 4, 3, 2, 1, go.
Welcome to the ReThink Food Challenge by Wageningen University and Research. A competition where food innovation meets entrepreneurship. The stakes are high. With limited resources, a growing population, and climate change pressing down on us, the need for sustainable circular food systems has never been greater. In this groundbreaking challenge, you won't just think creatively, you'll act entrepreneurially, form interdisciplinary teams, tackle real-world problems, and create viable business-driven innovations for food production on Earth. Whether you're enhancing existing technologies, developing new ones, or reimagining food altogether, your ideas could bridge critical gaps in global food systems. Guided by leading experts and industry mentors, you'll refine your concepts and build skills every step of the way. You'll gain insights into market demands, craft actionable business plans, and pitch your solutions to leaders in food, technology, and sustainability. The journey to the finals in May 2025 is more than a competition. It's a launch pad for your entrepreneurial career. Are you ready to take the leap and create the future of food? This is your moment.
Okay, this challenge is officially opened. I would like to thank you all for watching at home. I would like to thank the audience. Please give a big round of applause for Sophie and Bart. Let's go to the networking drinks and give each other